everybody, it's Charlie again. It's been a while since I've done a video, so I wanted to create something new because I got a project going on. This is going to be advanced fiberglass mold making. What I mean by advanced, it means it's either multi-part molds, molds that have inserts, threaded inserts, removable inserts, whatever. That would be an advanced mold, something with multi-parts that's actually very complex to actually produce. So without further ado, I'll pull this off of here. I'll give you a picture of what my project is, and then we'll cover some other basics of previous molds that I've made in the past that are not in the video. So anyways, stand by and we'll take a look. If you hear any noise in the background, I got a light fan going. It's like 95 degrees out. It's a scorcher out today. I'm in the shop. At least I'm in the shade, but the humidity is just terrible. We had rain a couple days ago and it's just melting me out here. Anyways, we are making a mold of a tank from a no longer produced motorcycle. This is from a 1978 Kawasaki. And I've made some changes to it to kind of modernizing it a little bit, and made it where it was moldable. So anyways, basically I removed the old fuel cap that was in here and I put a 6-bolt flange style fuel cap in here because those are readily available and produced. So I'm able to make the tank and then put the flanged keyless cap in here. Basically the tank was dent free. I was really happy with that, so I didn't have a lot of body work to do to the tank. I just stripped it and then re-primered it. You'll see on here I have my center line, which is just penciled on, and then but to come back on here, these holes right here are threaded. So when we go to make this thing, the mold, I'm actually going to thread bolts in these holes and we're going to mold around the bolts. That's one portion of a complex mold. And this part of the tank is going to get molded independently. And then each half of the tank will be molded while this particular mold form is actually in place. And to do so, we're going to use this PVC coupling. I happen to take and clean the ridge out of the coupling because when we put this on here, and I machined this surface flat because on both sides they have a tapered hole or entry point, and I didn't want the tapered entry point. I wanted it to be able to sit flat up against the opening just like this. So we will be molding, it wants to slide, so we'll be molding the interior portion of it in this covering here. So before we start, I will apply some tape in here, basically like 4 corners squared out, so I can still get my finger in there to tack it, and then cut a circle piece of tape and put over the hole that's still left. I'm not worried about it being super strong. It's mainly there to just give me a point of where I need to cut the flashing out whenever it's molded. So if you'll hold on a second, let me flip this tank over. Okay, now we have the bottom side of the tank. This is dramatically cleaned up in comparison to what the original underside of the tank was. It had these basically petcock openings. They were back here for this particular tank. This tank I want it for a custom project. Having the valves and the tank's going to be elevated in the back, so having the petcocks at basically a midpoint or high point of the tank is not correct. So I moved and made these plates. These holes here are threaded, and then this is just convex to give me a point where I need to actually cut that out of the part. Also on the particular bike, as I was doing this underside, there is a electronic unit that sits on top of the frame, and that needed to fit inside this portion of the tank, so I had to cut this section out of the tank and then make this form in here. So that's formed to fit this tank. And then lastly, if you're familiar with motorcycle tanks, they have a metal circle here that's this shape. and that's made to go around to lock the front of the tank down. So, and you can't fiberglass that little piece, so there was a lot of body filler that was applied in here, filling it in. So now that those cutouts here are molded into the tank and will still hold their, or still do their same function they were supposed to do, but in the interim gain some volume in the tank. So, and then I've also thickened up the actual area where they crimp weld the tank halves together. And I did that because when you make a mold here, it's only going to get molded to this outskirts lip here, and when you apply your glass material on the inside of the mold, it's going to get thick. So, and it would be thicker than what this metal was at that point by the time you make this top section. So I compensated it by adding material on the inside of this lip, so when I mold the interior portion of it, that glass is going to get laid up and then will come this way, so that the two halves will meet and potentially be about this thickness right here. Also, on the original tank, it had a section back here to mount to the bike. With that being said, I didn't want that, and it was not going to work for our particular use. So I added a fiberglass extension to the back of the tank, which is a good raised area, so I can put my quick release hood portion back here. So when you're making an advanced mold, you got to really think of how your part needs to be made. If you're going to have threaded inserts, pockets. When it comes to making each section in this video, we'll cover how I would go about producing segments of this. At this point, I haven't really given a lot of thought yet, but I'm going to assume at this point this is probably going to be a two-part mold just in itself, molding this under section of the tank, simply because of these pocket cutouts here. The rest of the tank, it has a gradual draft and some pretty serious radiuses on the edges, so the mold will naturally want to come out this way. But you won't be able to pull it out this way with these right here, so this section up here will have to be molded separately. And then of course it will have bolts molded in there so that I can have the threaded inserts installed whenever I fiberglass it up. So anyways, that's that. All right, everybody, we're back. This is a mold that I made for an old Ducati project a long time ago. This is the underside of the seat. And it was going to house tail lights and the brake lights all in this unit. So as you can see, it's rather a complex mold, simply because you have these light pockets that are molded in it, and it has a pin. So in order to achieve these particular functions in there, when I had made my master or my plug, I made it just like I wanted to mold it. And then I had to make these inserts first in the actual part, and then make the mold. So, and what I mean by that is each one of these inserts, and they are also marked left and right so that they could be installed back in the correct position. This one's obvious, it's much larger. But these parts have a slight draft or taper to them on this rounded portion of it. And then they are locked into the mold by bolts. The bolts basically are finger tight, so we'll just pull a couple of bolts out, and the parts. Like so. Okay, so this is an insert. So I'm wanting to have this insert inside of the mold or molded part to replicate. So how I achieved that is I took my master and I waxed it all up, etc., and then laid fiberglass and gel coat all in the inside of it, and then had to continuously mix putty and fill it up till I made this solid. This thing's solid as a rock. It also has threads cut in it, and it has a nut that would fit this particular bolt inside, fiberglassed inside of it, so I had actually a piece of steel to lock into to keep it strong and secure in there. So same thing with this. It's got a nut inside there, it was all filled in, but it is fiberglass and it's ready to go. So what happens is you make all of these interior parts first. And then I cut it to shape, gave it a nice radius, roundness to it so that there's no undercuts or anything that would prevent it from coming out of this mold. So that's all undercut and radiused out. And as you can see, once I had that, I installed these back into the plug and then had them set in position. And then I laid up the mold, and you can see as it molded these pockets into the actual mold. And then whenever I go to take the part out, I just pull the bolts loose. This part is actually rather a simple mold. The part is a dump mold, so it's a single part this way. Pull the part out, and then it leaves me to remove the plugs out of the part that I'm gonna make. So I have to, then in turns, I have a T-handle bolt that I thread into the part, and then I could easily just pull this right out of the part. Now bear in mind, when you do things like that, they can be rather tough, difficult to get out. But I don't make a lot of production parts off of this. So henceforth, the simplistic design of using the plug, and hence also adding draft. And what I mean by draft is it has a slight angle, so it gets, the farther it goes into the part, the shallower or the smaller diameter is, so that helps with trying to get the part out. So, and then of course this mold has a pin, and what that pin was for was to have a bolt, a screw that would come through, so I'd mold this pocket into the part and the bolting shelf on there, and then whenever I was done, I would trim it, and so that it would be flush with the top of this, so that I had the correct thickness. So anyways, that's basic mold with having inserts. So hopefully this will give you some ideas for whatever project you're working on, just how you think of doing an advanced mold like this. So now that we have this, all right, we're back. All right, so the tank, like I said, has 6 screws that needs to go in there, and I want to be able to put threaded inserts into the actual final product that I'm going to produce out of the mold. And I have some basically the brass inserts that when they're actually used in the production of the part, that will get laid up in the material, so that they're a permanent fixture to the tank. So, and then when it comes to bolts and hardware and things that I'm using, I don't like to use anything with Phillips or flathead. Everything's either going to be a socket head screw, or a cap screw. This one here is just a standard M4 bolt with a standard hex head on it, or I'll use an Allen driver or hex driver type screws, something that I can actually put some force on it, because generally when you go to break these free, they can be a little stiffer because the mold is precisionally copying the screw. So anyways, all these screw holes in here are threaded. So we set it up with these bolts in there like so, and it'll go all the way around, and then we will be fixing this onto here. And what I will do is I will apply some tape in here, so it'll help get it off here. The PVC is pretty good about releasing anyway, so I may not, but I still may, because I actually cut this in half. It was a PVC coupling, so I lost probably a 32nd of an inch, so it's a little bit out of round, which I'm not too worried about, and because of it's rounded. And then this tank is going to be molded. This will be the center line of the tank mold. Stand by here, it screws out. And the reason I chose doing the parting line of the mold being down the center line of the tank is simply because of this flanged area, and the 2 bolts, top and bottom, would be down the center line of the flange, which doesn't provide a good surface for holding bolts in place. And another reason is because of the tank shape. There's this undercut right here underneath the tank where the flange comes out, where they join the original tank. So if I was to go this way across the tank, I wouldn't have been able to they would only be able to pull the mold off this direction, which is not good. And it may not work in all axes, and because of this one I would have to mold it way up here, and then I'd have this flange, and I don't want that. So henceforth you have to really go through and study how you want your part to come out. Think about undercuts, think of how when you're trying to pull a rigid mold off of a rigid part, it has to naturally want to come off, or you'll have trouble, or you'll break your mold just trying to get the part out. So henceforth, center line makes it the most simple for being able to fold the mold off this direction, or basically this way. So simple there. When I come back, we will start to set this up. I'm going to be using, I got to get the tank waxed using my mold release. Once I get the mold release on, then we'll start setting this up, get this taped in, and then of course, like I said, I machine this. What we're going to use to hold this in place once it's ready to go is a hot glue gun. I'll apply hot glue once I set the flange together, like so, around here, get it in position. I will hot glue it in place. That way we can start laying up our fiberglass. So anyways, when I come back, we will have this waxed and we'll start moving forward. See ya. All right, so I now have one half of the flange on. I used the hot glue gun, and after this has been waxed 5 times, and then so I glued this half on there using my pencil line as my guide, because when you set the 2 up, there's going to be a slight crack in there. So what I'll do is I will apply tape on the inside of this to seal this crack on here, and it gives me my tapered fit. And I applied, this is just some duct tape. I don't really care about that whole surface there, so when I pull the mold or this part off, that'll come out. It'll be rough looking, but I don't care about that portion of it. It's like I said, it's only there to mark what that hole. Anyways, so now when you do this, I don't know if you can see it, I'll try to get it in there, but there's a slight crack or a gap between this and the tank. And what I'll do is when this glue is set really good, I'm going to go ahead and we'll come in here and I will scoop out some of the wax with my finger, and I will spread it into and fill that crack so that my gel coat doesn't leach out. If you got heavier cracks, you can use modeling clay. I use modeling clay a lot, especially for issues like that. Come in here and spread that out, because what will happen is if you don't close this gap, you can potentially fix it after you remove this portion of it to complete the rest of your mold, but it will have flashing underneath this, and you would have to clean that flashing up. So when you lay this other half of the mold, you would be molding the flashing into it, so you'd cause an imperfection at the seam. So henceforth we want to try to plug that up. So I'll get this plugged up. I'm going to get the other half on, and then when we come back, I'll have the screws installed. I've already went through all my screws, and I've actually waxed them with the exception of the nut. Ran the nut up to a distance because I want to actually, this is such a small thread, and potential of use over and over and over could actually damage the threads in the fiberglass. So I want an actual steel in there, so I will mold those nuts inside the mold. So anyways, we'll come back, I'll have this all done. This mold flange will be on here, and then we'll be ready to start adding gel coat. So that's it. The mold has the clamshell here that I made to go around is in. The screws are installed, and if you can see on the bottom corner, there's some blue. That is because I took the paste wax and then I kind of smash it into the crack. I'm gonna put it in there, and then there's this, it's all hot glued in place. And then this crack here, I used this is 3M precision masking tape. I really like this stuff. It's super thin, really pliable, sticks really well, so it works great for putting in here. You can see all the bolts are in place. Now this is going to be a very difficult part to make, simply because trying to get glass down in there. So most likely what I'm going to do is I'm going to come in and I will paint the gel coat in first, my tooling gel coat. If you're not familiar with what that stuff is, you can watch my molding basics and check that out, and then it'll kind of help you with some more of the materials. But I'm going to put my tooling gel coat down first to create my surface for the mold. So the gel coat will go in, and then when that's done, I'm potentially going to mix up a resin, make it kind of thick with fiberglass fibers. I'll probably chop some up with scissors, and I'll use some of my milled fibers and basically pour it in here to kind of fill up above those nuts right there. And then after that, I can actually layer glass in, which won't be that big of a deal. My main concern is the actual mold surface, not the flange surface that I'm trying to achieve to bolt the halves together. Just this can have, you know, air bubbles are not as critical, but air bubbles against the actual molding surface is bad. So anyways, we'll come back. I'll have the red gel coat in, and we'll be waiting for that to cure, and then we'll come back once. All right, the first coat of gel coat is in. It's much heavy down at the bottom, and you try to get it as heavy as you can. When I'm painting it with a small acid brush or a horsehair brush. They're cheap and disposable, so I buy them by the boxes. So I come in, mix a small amount of gel coat, and then do this in here. When this goes to cure, I'll come in and I'll apply a second coat in here, simply because when I wet sand, I don't want to break into the actual fiberglass material that will be underneath. So I will apply a second coat on here, and then we'll move forward. All the screw heads that actually have gel coat on it, when I'm going to apply it in here, I'll come in here with a Q-tip and I'll wipe those off, just simply because I don't want, and when that stuff is cured, it's very hard and it will bond to the steel and be difficult to get off. So anyways, I'm going to get those cleaned up, we'll let this cure, and then we'll come back. I'll have the second coat in and we'll work on the glass. So the next time we come back, we'll be doing the actual glass work. So that's it.